Okay, so just quick review then, okay? Because this list here is kind of like the real world situation. There's some ionic compounds on here. There's some molecular compounds on here. There are some ionic compounds that will need Roman numerals. There are some that have polyatomic ions. It's a little mix of everything. Okay, the challenge here is obviously to be able to determine which one's molecular, which one's ionic, which ones need the Roman numerals, okay, et cetera, et cetera. So let's just quickly review how we can tell that. First off, I know it's ionic if it has what in it? A metal. Okay, if it's got a metal in it, it's ionic automatically. Okay, however, I could have an ionic compound that starts like this, doesn't really have any metals in it, because it starts with, well, with a polyatomic ion, right? With ammonium, that one that's positively charged and behaves like a metal. Okay, but I mean, this is like 99.99% of the time it's got a metal in it, okay, or starts with a metal, it's ionic, okay? So we know that one. If it's got two nonmetals, then it's molecular. Okay, so if it's ionic, do I need prefixes? No. All right, I name the metal, I name the nonmetal. All right, if it's ionic and I've named the metal and I've named the nonmetal, how do I know whether it needs a Roman numeral? Right, if I look on my periodic table and I see that that particular compound has more than one possible charge, and if it does, then I have to determine, okay, using the rules we learned yesterday, okay, which Roman numeral it would require. All right, and if it has a polyatomic ion in it, do I do anything different? I name the metal, I name the polyatomic ion. Do I change the name of the polyatomic ion at all? Okay. If it's molecular, then I name the nonmetals in order. Last one's name gets changed to I, right? Ends in I. All right. Okay. Give these ones a try here, okay? And then I'll walk through a few at a time as we go along, okay? Just see how we're doing with that. Okay, so we'll write the metal out because it's ionic, okay, and then the nonmetal ending in "ide." Okay, do I need anything else on that one? No, lithium doesn't need Roman numerals because it only has one possible charge. Okay, number 2, I've got chromium with fluorine, ionic or molecular? It's ionic, chromium's a metal. Okay, so chromium fluoride. Okay, do I need anything on that one? Yes, chromium has more than one possible charge. All right, so fluorine is always a -1, okay? Chromium, and there's 3 of them, so that gives me 3 negative charges. I only have 1 chromium to get 3 positives from, so this must be chromium 3 fluor. Okay. All right, what about number 3, ionic or molecular? It's molecular, okay? Phosphorus and bromine are both nonmetals, so this will be phosphorus. Okay, we don't use a prefix on the first one if it's mono. And then, what's the prefix for bromine? Tribromide. Okay, and then number 4, I have zinc and iodine, ionic or molecular? It's ionic, okay. So, zinc, iodide. Do I need any Roman numerals on that one? No, zinc only has one possible charge. Okay, how many people are done up to number 6? Okay, so let's go at least that far. Okay, number 5, I've got silicone and oxygen. Ionic or molecular? It's molecular. Silicone is a nonmetal. It may be a solid, but it's a nonmetal. Okay, so silicone dioxide. Okay, for that one. And then for number 6, I've got carbon and sulfur. Ionic or molecular? It's molecular. Okay, so this will be carbon tetrasulfide. Okay, seems like we're getting it. All right, finish those up, guys, and we'll go through the rest. Okay, so this one is ionic. Okay, so it will be technetium iodide. Okay, and you'll notice every time I do one of these, I go through the same set of steps, right? The first question I ask myself is it ionic or molecular? Okay, then I write it out and I ask myself if it needs Roman numerals and all that kind of stuff. It's just kind of a set of steps to follow to make sure we get them all right. Okay, number 8. I've got sodium and oxygen and hydrogen. Ionic or molecular? It's still ionic, but the OH at the end is a polyatomic ion. All right, so what is the name of that polyatomic ion? Silicate hydroxide, right. So this will be sodium hydroxide. Okay, remember it doesn't change what we do in terms of naming, we just write the name of the polyatomic ion. Okay, for number 9, I've got calcium, and it's with another polyatomic ion, which technically in this one wouldn't need to be in brackets. Okay, I only actually put brackets, I'm going to put a number outside of them. Okay, so this one doesn't technically need them. Okay, so this is calcium with sulfate. So this will be calcium sulfate. Okay, and number 10. Okay, I've got potassium with another polyatomic ion. So this stuff will be permanganate. Yeah, this stuff is potassium permanganate. It's little purple crystals. But if you touch the crystals, they dissolve in the oils on your hands and stain your hands brown. So, don't touch them. I once had a kid in my class, we did a lab with this stuff. This kid never listened to a word I said ever. And I told the class like 10 times, make sure you use the scoop when you're picking up the potassium permanganate or it'll stain your hands brown. Now, you have to imagine, this kid was like pasty, okay? And he comes up to me in the middle of the lab and he's got the dish and he's doing this. And he's just playing with them with his bare hands. He's like, these are so cool, Mr. Coder. I'm like, uh-huh. You looked at your fingertips. Brown, all around the fingertips. And like, short of bleach and sandpaper, that is not coming off anytime soon. So he walked around with brown fingertips for like 2 weeks. Yeah. Maybe you'll listen a little more. He didn't. Sadly true. Okay, how many people are done the rest of those? Okay, I'll give you like another minute here just for those of you that aren't quite done, and then we'll go through the rest. All right, let's look at the rest of these here. Okay, so number 11, I've got nitrogen and oxygen, ionic or molecular? Molecular. All right, so this is nitrogen monoxide. Okay, number 12, I've got beryllium and a polyatomic ion called cyanide. Okay, so this will be beryllium cyanide. Remember, guys, that none of these should be capitalized, so if you've been doing that, make sure you try and break that habit. Okay. For number 13, I've got barium with cyanide, so this will simply be barium cyanide. Okay. Number 14, sodium with HCO3. What is that stuff? Sodium hydrogen carbonate. It's also sometimes called sodium bicarbonate. Baking soda is actually what that stuff is commonly referred to as. Okay, and our last one, phosphorus and oxygen, molecular or ionic? Molecular, okay, so this will be phosphorus. What prefix am I using? Tetra. Okay, questions on any of those? All right, now we have to look at going the other way. Okay, what if I give you the name and you've got to come up with the formula? Right? Well, for molecular compounds, that's super easy. You just use the prefixes to tell you what numbers to write. Okay, so they're really, really easy. With ionic compounds, they're not really hard. We just have to keep in mind that we've got to balance the charges, and we do that by doing the drop and swap, or swap and drop, whichever way you were taught it. It doesn't matter, because in the end, it ends up in the right place. Okay, so if I'm looking at, let's do an example here. Let's say I've got lithium nitride. Okay, first off, ionic or molecular? as a metal. All right, so my first step then is that I write out the symbol for lithium and I write its charge. Its charge, according to my periodic table, is +1. Okay, nitride is nitrogen. Okay, so I write out the symbol for nitrogen, which is N, and its charge, which is -3. And now I do the drop and swap. Okay, so I drop the 3 and swap it over. I drop the 1, swap it over. We don't write 1s in a chemical formula. Now I'm done. Li3N. Now my charges are balanced. Okay? Because every lithium is a +1 and I have 3 of them, I have 3 positive charges to offset the 3 negative charges of the nitrogen. Okay? So the drop and swap is just kind of a quick way to balance the charges without having to really think about it. The only time the drop and swap will fail you is if the numbers can be reduced after the fact. Okay, so if I had something that was like 2 and a 4. So let's go with this one. Lead 4 oxide. Okay, what does the Roman numeral tell me about lead?
There's 4.
Not that there's 4. That lead has a charge of +4. Okay, that's the big confusing thing that usually happens with this. People see that 4 and they go PB4. No. Okay, it doesn't mean there's 4 leads. It means the leads have a charge of 4. Okay, so we're going to write PB +4. All right, what's oxide's charge? -2. All right, so now when I do the drop and swap, the 2 drops and swaps over to here, the 4 drops and swaps over to here. Okay? Sorry, that's a 2. Not whatever that other thing was. Okay, so I have to reduce that. With ionic compounds, if I can, I reduce them to their lowest form because that's the way they would actually go together. All right, so I wouldn't leave this as PB2O4. Okay, I would leave it as PbO2. Okay, always reduce my ionic compounds. Would I reduce a molecular compound in the same situation? No, because I would have got those numbers from the prefixes, and those prefixes actually tell me this is how many there are. Okay, remember that in a molecular compound, we're not trying to balance charges. Okay, we have to do this because that's what balances the charges. All right, so that kind of goes over the Roman numerals. Okay, another situation you can run into is if you have a polyatomic ion like this. All right, so I've got calcium nitrates. So same as before, I'm going to write the symbol for calcium and its charge, 2+, and I'm going to write the symbol for nitrate, NO3. And it has a -1 charge. Right. So now when I drop and swap, okay, the 1 will drop and come over here, but we don't write 1s. The 2 will drop and come over here. And I think we talked about this yesterday. Okay? Do I want to leave it like that?
No.
No, because that says there's 1 calcium, 1 nitrogen, and 32 oxygens. That is not what is going on here. Okay, what is going on here is that calcium has bonded to nitrate, and 2 nitrates are needed in order to balance the +2 charge of the calcium. Okay, everybody all right with that? So, in an ionic compound with a polyatomic ion, the number attached to the polyatomic ion will not change. You'll put it in brackets and put another number out there. Okay, that's how we make sure that those work. That's when we need brackets. If they're already balanced, like this one, okay, then we wouldn't need brackets. Magnesium is a 2+, sulfate is a -2, those already balance. I don't need to put any other numbers there, so I don't need any brackets. Are you all right with how that works? Okay, so like I said, molecular is really easy, just go with the prefixes. Okay, with ionic, you got a couple of things to remember. Okay, when to use brackets when you drop and swap, don't change these numbers. And the Roman numeral tells you the charge. Okay. All right. Okay, I want you to try a couple of these ones here. We've got what? Oh yeah, we still got left. Okay, so let's say try the first 6. Okay, so you're writing the formula for these. So for our first one here, we got calcium phosphide, ionic or molecular? It's ionic, so I'll have to do the drop and swap on this. So calcium, 2+ charge, phosphide, -3 charge. Okay, so I take the 3, push it to here, take the 2, push it to there, Ca3P2. All right, are you okay with that? Then we got cesium oxide, ionic or molecular? It's ionic. Okay, so we got Cs, and it's 1+, right? And it's with oxygen, which is a -2, so we drop and swap. The 1 goes here, but we don't write 1s. The 2 goes here, CS2O. All right, number 3, manganese IV oxide. So we got Mn, okay, which is according to this formula, what charge? 4. And it's with oxygen, which is a -2. Now, I can already see that when I drop and swap those, I'm going to get 2 and 4. So I should automatically reduce to 1 and 2. Okay, so I should have MnO2. All right, for number 4, I've got iron 2 sulfide. So iron is Fe, and it tells me it's the 2+ Fe, and it's with sulfide, which is a -2. Okay, do those already work out? Right. So I wouldn't write Fe2S2, would I? No, I reduce it to 1 and 1. Okay, anytime you can reduce it, you do so. Okay, or you just look and see that these are already balanced and you don't need to do anything with it. All right, so we've already done potassium permanganate because that was on our other one there. So K with a +1, okay, and then permanganate MnO4, okay, which is a -1. So this is already balanced the way it is, KMnO4. And then silver chloride. Silver is Ag with a +1. Chlorine is a -1. So that one's already set up. Okay, just making some sense. Good. All right, so why don't you just do a bit of practice with that today out of your chemistry workbook package. All right, so that was in Google Classroom. Okay, I'll call it up on here, and I will post the keys for it in Google Classroom with today's recording. All right, so if you're working on it, you can check the keys as you go.